In this video, we will be practicing with balancing chemical reactions. Our first reaction is here on the board already, and we're going to go through and see if it's balanced. And if it's not balanced, we need to go through and make sure that each of the number of atoms on the left side is equal to the atoms on the right side, which would make it balanced. So let's take a look here. Now, looking at what we have here, you may not easily be able to just recognize whether it's balanced or not. So what I like to say is to practice with using an element table, okay, to list what's on the left side, what's on the right side. Eventually, you will most likely be able to just balance using inspection and just inspecting it and looking to see, okay, what isn't balanced. But having this option as well helps to help you with visualization to see what's on the left side and what's on the right side of my chemical equation. Now, the rule of thumb that we are going to follow when balancing chemical equations is going to be that you start with metals, then you move on to nonmetals, then you do hydrogen and oxygen last. These two, you can do them in either order, but what I found to be quite helpful is to do hydrogen first and then oxygen. Okay, so let's go through our elements that we have present in this chemical equation. We have one metal, which is potassium. So let's start with potassium here. Then we have a nonmetal, sulfur, and then what's left is our hydrogen and oxygen. So now, beginning with potassium, we look on the left side and we see where potassium is, and there's only one potassium on the left. On the right, we see that this potassium has a subscript 2. That indicates that there are 2 atoms of potassium on the right side. So now immediately we see we have potassium is not balanced. We have 1 on the left, but only 2 on the right. Or we have 1 on the left and 2 on the right. So we only have 1 here. So we need to make this 2 on the left side. So in order to balance, what we are going to be adding is what's called coefficients. And the coefficient is the number that goes in front of the compound's chemical formula, and then that number gets distributed to each atom within the chemical formula. So by putting a 2 here in front of the KOH, now this tells us that there are 2 potassiums here. So now our potassiums are balanced. Let's move on to sulfur. Looking on the left side, we find sulfur here in H2SO4. We should recognize the name of this is sulfuric acid if we review our naming. So sulfuric acid contains 1 sulfur atom. And then here in our product side, we have potassium sulfate, which contains 1 sulfur atom. So sulfur is balanced now. So let's move on to hydrogen. Now looking on the left side, we see that hydrogen is present in the potassium hydroxide as well as in the sulfuric acid. So we need to add together the hydrogens that are within the potassium hydroxide and the hydrogens that's within the sulfuric acid. Now we have 1 hydrogen here in the potassium hydroxide, but we have a 2 in front. So this distributes to indicate that we have 2 hydrogens from the potassium hydroxide, and then 2 hydrogens here with the subscript for sulfuric acid. So 2 plus 2 gives us 4 hydrogens on the left. Now looking on the right, the only hydrogen present in the products is the hydrogen in the water. That's 2 hydrogen atoms in the water. So we say only 2 hydrogens on the right. Now we recognize this is not balanced. We have 4 hydrogens on the left, but only 2 hydrogens on the right. So we need to add 2 more hydrogens on that right side. So we want to make it 4. So by putting a 2 in front of the water molecule there, now that's going to give us a total of 4 hydrogen atoms. And then the final element that we'll have to balance is the oxygen. Looking at the left side and the right side, we see that on the left, we have oxygen present in both reactants. So we need to add them together. So we have 1 oxygen here, but with a 2 in front, that 2 gets distributed. So we have 2 oxygens plus 4 oxygens in this subscript to give us 6 oxygens on the left. Now here we have the 4 subscript for this oxygen, and then 1 oxygen here, but the 2 gets distributed. So 4 plus 2 oxygens gives us 6. And now your chemical equation is balanced. So usually once you get down to the oxygens, at this point the equation should be balanced, but sometimes that's not always the case. But we always want to double check. So that's why I like to use the table. But if you can eventually get to the point where you look at the equation and you can inspect it and identify what's not balanced and add in the coefficients, that's fine as well. I just like to have this as a good option for students to fall back on if you ever get stuck. Okay? So let's move on to our second example here. So this video is going to be a little bit longer than our usual videos, but I want to do all 3 of these examples in one video. So now this next chemical equation that we want to balance is KClO3. This is potassium chlorate. If we practice our naming, potassium chlorate decomposes to form potassium chloride, which is going to be also a solid, plus oxygen gas, O2 gas. Okay, so this one's a fairly simple equation, but I'm still going to go through using the table. But if you can recognize without using the table, that's perfectly fine. Okay. In this equation, there are 3 total elements. There is the metal, potassium, there's the non-metal, chlorine, and then there is oxygen. So this is the order that I'm going to balance. Looking on the left side, we have 1 potassium. Looking on the right side, we also have 1 potassium. So potassiums are balanced. Chlorine, 1 chlorine on the left, 1 chlorine on the right, balanced. Okay. Now when we get to the oxygen, this is where it's going to be a little bit less balanced. We see that there is 3 oxygens on the left and 2 oxygens on the right. So now in this case, we need to make some changes to our chemical equation. And the way that we do that is by adding the coefficients. And when we add a coefficient, remember it's also going to get distributed to the other elements in the compound. So looking here at potassium chlorate, we have 3 atoms here, okay, but we want to figure out what number we can put in front of here to make a multiple that's the same on both sides. So by multiplying this side by 2 and this side by 3, we'll be able to get 6 on both sides. So by putting a 2 in front, this gives us 6 oxygens. And by putting a 3 in front of the oxygen, 3 times 2 now gives us 6. But what happened here on the left side, when we added a 2 in front, we see that Oh, shoot. Okay, I think it stopped recording for a minute. I believe that stopped recording for a moment. So I'm going to keep going now. I think I fixed it, but I'll double check it when I'm done with the recording. Okay, so now what we recognize is that by putting the 2 in front of the KClO3, we got the 6 oxygens, but now it has changed the number of potassium and the chlorine to 2. The 2 gets distributed. So this is now 2, and this is now 2. So now we have to go back to rebalance the right side for potassium and chlorine. And to do that, we will place a 2 in front of the KCl, which gets distributed to both the potassium and the chlorine. So that completes our second example, and we see that we have a 2 in front of the potassium chlorate, a 2 in front of the potassium chloride, and a 3 in front of the oxygen, which gave us our balanced equation. Our third example is going to be a little bit more challenging. We are going to have a combustion reaction in this equation. So we are going to have C4H10. This is actually butane gas. You don't have to know the name of that, but this is butane gas. When we react that with oxygen in a combustion reaction, we form carbon dioxide and water. And the water exists in vapor form because this happens at very high temperatures. Okay, so let's begin here by going through using our table. We're going to have the elements in the middle, and then our left side and our right side. And then we look to see, do we have any metals? No metals in this chemical equation. Do we have any nonmetals? We have carbon, hydrogen, and oxygen. So we will start with carbon, then move on to hydrogen, then move on to oxygen. Remember, you can do this in whatever order you want, but this is just a rule of thumb to follow. So let's begin with the carbon. There is 4 carbons on the left and 1 carbon on the right. So we need to balance the carbons by putting a 4 in front of the carbon dioxide gas. Okay, so now the carbons are balanced. Let's move on to the hydrogen. We have 10 hydrogens on the left, and we have 2 hydrogens on the right. Okay. So what we can do here to balance is that we can multiply the 2 by 5 to give us 10. So we're going to put a 5 in front of the H2O, which gives us 10 on the right. Now when we get to the oxygen, let's count how many oxygens are on the left. For oxygen, we only have 2 here on the left. But on the right, we have oxygen present in both the carbon dioxide and the water. So now we have 2 oxygens here in the subscript, but the 4 gets distributed. And when we distribute to a subscript, we multiply. So this is going to be 4 times 2 is 8 oxygen here, plus, now we have 1 oxygen in water, but we have 5 of them. So 5 times 1 is 5. So 8 plus 5 equals 13 oxygens. 13 oxygens on the right. We will recognize that this is an odd number, and here we have 2. So 2 doesn't evenly go into 13, but the common multiple there is going to be 26. So we're going to need to multiply this side by 13, okay? So when we multiply this side by 13, I'm going to put a 13 in front of the O2. That's going to give us 26. And now we need to multiply this side by 2 to get 26 oxygens on the right. So if instead of having 4 coefficient here and 5 coefficient here, we're going to multiply both of those coefficients by 2 because we want double the amount. So we're going to multiply this by 8 and this by 10. And now let's check to see if we get 26. 8 times 2 is 16, plus 10 times 1 is 10 to give us 26. But what else has changed now that we changed the coefficient? We've also changed the number of carbon and hydrogen. Now we have 8 carbons on the right and 20 hydrogens on the right. 10 times 2 gives us 20. So then looking then on the left side, if we have 4 and 10 to give us 8 and 20, we multiply the butane gas by a coefficient of 2, which will now give us 8 carbons and 20 hydrogens. And now this equation is balanced. So like I said, this one was a little bit more challenging because it had to go back and forth a couple times, and we had an odd number here, but just take your time when you're thinking about it and try to simplify it as much as possible. Overall, whatever thought process you use to get you to the correct balanced equation is fine, okay? I like to use this table just as a good visual so you can kind of keep track of the changes that you are making as you're changing the coefficients. Okay, very good.